Okay, let's do question for 17 using Minitab. Again, I already entered the data in two columns, technician 1 in column C1 and technician 2 in column C2. So we go to basic statistics. Now we have two sample t-tests. We're going to be using two sample t-tests. The first option here, we have both samples are in one column. No, I pull the button down. Each sample in its own column. Yes, this is what I want. Now sample 1 is in C1 technician 1 and sample 2 is the technician 2. Since we want a two-sided confidence interval for the options and a 95%, so I'm not going to change anything here. And I'm going to click assume equal variances because that's what's given to me in the question. So I'm going to click OK and click OK. So now we have, let me pull this down. We get the results here. Mu1 is the population of mean of technician 1, mu2 population mean of technician 2, and here we have the descriptive statistics, each sample, number of samples in each sample, and the mean and the standard deviation and the standard error of the mean. Here we have a two-sided confidence interval, which is the answer to part C. So now let's first go to part A, which is the hypothesis testing. We have here mu1 minus mu2 is equal to 0 versus the alternative mu1 minus mu2 is not equal to 0. The t value is 0.19. And the p-value is 0.85. Again, since the p-value is greater than alpha 0.05, so we fail to reject each node and therefore conclude that the two means are equal. Therefore, the two technicians perform equally as good. Now, for part C, we have the two-sided confidence interval, and as you can see, the two-sided confidence interval, it is minus 0.1187 to 0.1419. Since 0 belongs to this confidence interval, then we also conclude that we fail to reject each node. This is another way to confirm our finding from the hypothesis testing.